Okay, now we're going to look at some different situations and choosing which data display would be the most appropriate. Sometimes there are multiple ways that data can be displayed, and so I'm just going to pick some that are most appropriate, I guess, and demonstrate that. So here we have appliances sold at Lowe's during the month of September. And there's several categories. There's not really an order that they need to occur. So I suppose since it's categorical, a bar graph would be the best choice here. So I'm going to go ahead and... So I went ahead and made some axes and labeled along the bottom my different categories. I could have mixed them up if I wanted to. The order doesn't really matter. Now I just need to scale my frequency along the side. So I'm going to label frequency. And then how about 4, 6, 8, 10, 12. There, my scale is labeled, and then I can put in my bars according to how many I have. So I've got 35 washers. So that's about right here. And my dryer, 21. My oven, '27 refrigerators. Okay, there. So I think my graph is really ugly. It's really difficult to write on this screen. And it really bothered me that I had 2 spaces here between my washer and my dryer, but that doesn't really matter. This is not a number line, and the spaces in between are okay, and it doesn't have to be uniform. This is the only case when it doesn't matter. So there, my graph is really ugly, but I think it looks like a lot of what students would show. Okay, let's take a look at another kind. So here we have boot sizes of the marching band. So which kind of data display would be appropriate in this case? Well, it's numeric data. It has order to it, so I am not going to want to choose the previous graph, a bar graph. Something that might be appropriate is a dot plot, and a histogram would work in this case as well. I'm going to go for a dot plot in this case because I've got numerous pieces of data that are the same. So let me get that set up. So I chose to set up my dot plot like this. I had a little conversation with myself about whether this should start on a number line from 0, and I decided, well, there typically is not a size 0 shoe, and this is just naming sizes collected, and so I decided to display it starting like this. A line plot is based on a number line, and so I suppose that it is a good idea to put that mark showing that 0, that there are previous values on this number line before the 8 occurs, and it is in order. If this were not on graph paper, there would be marks above each of these numbers showing where to line up our dots. On graph paper, I decided to put the numbers in between the lines so that I could put my dots, or whatever other marker I wanted to use in between to display that. And very frequently I'll put a bar and just or use squares on a piece of graph paper in place of a dot to make graphing these done pretty quickly. Okay, assuming I have not miscounted, the dot plot would look like this. On this particular case, I am currently missing the label on the bottom where I should label this shoe size. And the label on the side in this case is not necessary, as in a dot plot each dot is representing one piece of data. If that were different than that, we'd need to have a way to make that clear. In this case, it's fine. All right, moving on to another. Okay, which display? A school survey showed that 135 students owned iPods, 53 students owned iPhones, 17 students owned both, and 246 students owned neither. So there seems to be two different categories, and this would be a nice example of a Venn diagram. So two circles for our Venn diagram. Have one labeled iPod, the other iPhone. And so outside would indicate my neither, so I'm going to put my 246 out here, my both, 17, iPod only, 153, and iPhone, 53. There. Now we're going to look at one problem and compare the different representations. So in this case, with the data that I see, I think that a dot plot would be possible. We've seen an example of that. A dot plot is not the best choice. There are too many different values. It would make it a really wide dot plot. So while a dot plot is possible, it's even better to use a stem and leaf plot and or a histogram. So let's take a look at how each of those look. Again, I really like using a stem and leaf plot to organize my data before trying to decide how I want to make the bins for a histogram. So I'm going to start with that. So here's my bar. The smallest are the 20s, and then I've got some in the 30s, 40s, 50s, and 60s here. So I've got 25, 28, 29, 30, 32, 2 34s, 2 35s, a 37 and a 38. And leaf plot. This would be another nice thing to be done on graph paper, especially for students with really rotten handwriting. Mine looks worse than usual trying to write on a computer screen. But the boxes would keep this lined up so you could actually see the shape. A lot of students have trouble keeping columns correct without the guidance. So this would be great to have graph paper. So now let's look at according to the shape that I see here, I think that it would make a lot of sense to use 10 years as a bin width and create a histogram. I suppose 5 years would not be terrible. It might be a little spread. It'd be a little dull in looking at the 20s, 50s, and 60s. So I'm going to go ahead with the choice of the 10s and set that up. And there's the histogram. It's not it's not perfectly symmetrical, but I wouldn't call it not symmetrical. It has a single peak, and there are no apparent outliers. So I would be very comfortable with using a mean or a median in this case, according to the shape of what we see here. And now let's take a look at a box and whisker plot for this. So we need to find our lower limit, our minimum, which we've got at 25. So we make a vertical line there at 25, and our maximum there at 63. So we make that mark there. I like to label, actually the 25 is not too bad, but it's a little tough to tell that I mean 63 here, especially if I'm not using graph paper. And then I need to determine my median. So for my median, I just counted, and there are 29 pieces of data. That's odd, so I know I have an exact center for my median. And so if I remove 1, I've got 28, and half of that's 14. So if I count backwards or forwards, 14, that leaves me with 43 as my median. So I'm going to mark that on here. So that leaves 14 pieces of data in the upper and lower, and if I count 7, that leaves me between my 34 and 34. So I've got an upper or a lower quartile here at 34. And my upper quartile lands between 46 and 47, so I've got a 46.5. So 46.5, perhaps in here. I can complete my box and put in my whiskers. Okay, so here's where we can show students that it's not about the area. We've got a nice connection to area over here in the histogram, but it's backward seaming here. We need to emphasize that there's 25% of the data in this space, in this tiny little space here. I wanted to quickly point out this style of table. I gave this problem to several of my students, and it was misinterpreted by many of them. We hadn't worked on frequency tables, and my students took and were using this this column as data points instead of being frequency. And so I just wanted to point this out as a style of table that might be used in 6th grade and something to teach students how to interpret. All right, the last thing I wanted to talk about is outliers in specific. I mentioned that in 6th grade we typically just look and see, well, 28 seems like an outlier here, so I'm going to guess that that's an outlier, but I wanted to fake away in high school and college that outliers are calculated are that they are determined by being more than 1.5 or 1.5 times the inner quartile range above Q3 or below Q1. So in this particular set of data, I found that Q1 is at 37, Q3 is at 40. So my inner quartile range is 40 minus 37, and that inner quartile range is 3. So if I take 1.5 times my inner quartile range of 3, I find 4.5. And I am looking back again at, I'm wondering about this 28. So if 28 is more than 4.5 below 37, then yes, it is an outlier. So 37 minus 4.5 is greater than 28. Therefore, 28 is officially, statistically, an outlier. So that's it for this week. If you have any questions or feel like anything is missing or just want to give me any feedback on how things are going, send me an email or give me a call. I hope everything's well. Have a great week.